Hello, you're welcome to my channel. My name is Solo Ange, and in this video we're going to deal with subtraction of vectors. Okay, so this is a part of the videos devoted to our lecture on vectors. So if this is your first time, you may have to check the playlist, then go back to the other videos to catch up with us. But if you're already familiar with those things, then we can get on with it. All right, good. Okay, and also if you are new to my channel, please consider subscribing if you find this video helpful, and also share it with your friends. Thank you for that. Okay, so subtraction of vectors. In our previous videos, one of them we dealt with addition of vectors, and then after that we dealt with the multiplication of a vector by a scalar, which then we are ready to now look at subtraction of vectors. Okay, so I would like to just start off with simple examples just to get us motivated already enough, right? To in short, it's actually very simple. It's just that I just choose to start with an example in this case. So let's say we have two vectors, vector u and v, and then vector u is given by, let's say, 1 0 1. Okay, very simple one. And then vector v is given by, let's say, 2 1 and -3. Good. So recall that these notations are also equal to this. So this notation is something as I plus vector k, while this could also be written as 2i plus j minus 3k. That is to say, this vector u has one pointing in the vector I hat direction, 0 in the just to say it's not even pointing in the, or it's not affected by vector j hat, and so on. Okay, and then this one as well. So you want to find out what this difference is. You want to find vector v minus vector u. Okay, so when we dealt with vector addition, I didn't just move on to subtraction until we consider what we call vector multiplication of a vector by a scalar, which we saw that when we have vector v, if it is pointing in a particular direction, then the negative will have the same size but pointing in the opposite direction. So this is what I would like to do. And okay, maybe that was not all. We were also able to discover that when we multiply a vector by a scalar, all we just have to do is to multiply every entry of that vector by that scalar. Good. So first of all, since we are given vector u, I'm going to consider vector u as negative u. And then I'm going to split this difference into the following. So I'll consider that vector u, v minus vector u, is the same thing as saying vector v plus negative vector u. Good. So you want to find out what minus vector u is, then we'll now add that to vector v. Vector v is given as 2 1 -3. So vector u has been given as 1 0 1. But what is the negative of that? Just multiply each of these entries by that minus sign. That would give us -1, of course 0, and then -1. So this is negative u. Good. Okay, so now we are ready to add. So to add these vectors, we just have to add the corresponding entries. That's what we discovered when we dealt with vector addition. So we say 2 plus -1, we just have that to be 1. That is 2 and -1. Then 1 plus 0, we have that to be 1. I wanted to say 0. Then -3 plus -1, that should simply be -4. So this is the difference between vector v and vector u. So what we had to do is to change it to addition, because that's what we know. But then we compute the negative vector u given vector u by simply multiplying everybody by -1 in vector u, and that's it. All right. Okay, great. So it's very simple at this point, but I'd like to visualize what's going on. Let's see what is really going on here, right? That's how I would like to learn this. So let me go to another page. Okay, so this was just an example to get us started, and I really like this process, this particular thing I did, because it's going to help us a lot in visualizing. Okay, so let's say we are given two vectors, vector v and vector u, and then let's say vector v points in this direction. Okay, so let's say that's vector v, and then let's say vector u points in this direction. Vector u just something almost horizontal like that. Okay, well, let's give it a little bit of steepness. Okay, so let's say that's vector u. So let me label that as vector u, and then let me call this vector v. Okay, so you want to find out what is, so you want to find v minus c. So you just want to visualize what's going on here, right? Good. So recall that we could rewrite vector v minus vector u as v then plus negative vector u. Okay, and we understood that once we say negative of a vector, that is to say you have the same size but opposite direction. So what we have to do is to just say vector v, which is being given. Let's use the diagrams. Vector v, which is being given as vector pointing in that direction. So we try to imitate pointing in that direction like that. Okay. Okay. Then we have to add that to vector u, but the negative. That's the opposite. The same vector but pointing in the opposite direction. So you think about having a vector in the opposite direction but having the same size, right? So this is now negative vector u, while this still stays as vector v, right? Good. We now want to add these two together. So recall, vector addition, we say that vector addition, we say given two vectors, then the addition u plus v is determined by saying taking the initial point, putting the initial point of the second vector v on the first vector u. And of course we also showed that the other way around, that is if you reverse the order, the result still stays the same. So we could simply say that this would be, to add these two vectors, we'll have to put the initial point of vector negative u on the terminal point of vector v. Good. So this will give us, so this is vector v, this is the terminal point, this is the initial point of vector v, this is the terminal point of vector negative u, then this is the initial point of it. So we want to put, first of all, put down the vector v, which has that direction, goes like that. That's vector v. Okay. Then we want to put the initial point of vector u minus u on the terminal point of vector v. So I'm going to try to do that. I'm going to still try to maintain the direction, but of course that's the direction of vector negative u, right? Good. So that's vector negative u. So this is where it's pointing. Vector u pointed this way. The negative will point in the opposite direction. So this is vector v, this is vector u. And what we now have to do is to add them together. Take note, addition. So by addition, I've said I have to put the initial point of vector negative u on the final point of vector v. So we see that we started from here. We started at this point, and this is where we end up at. So that is the sum of those two vectors. That is the sum of vector v and minus vector u. Okay, so that's where the sum takes us to. But then vector v plus minus vector u is something as saying vector v minus vector u, which is what we wanted to find. So this is how to visualize the difference between two vectors. So you want to take the difference between two vectors, which is actually vector v minus vector u. What we just have to do is negate that vector u that's changed the direction, and then add them together. So this is how it is. All right, good. Okay, so how does this help us in terms of giving us where to go? Well, we started off here with an example which we were able to just say subtract them. We could simply just say subtract, like saying 2 minus 1 is 1, 1 minus 0, that's subtract the corresponding entries, is 1. Then negative 3, okay, let me use this. This is to find v minus u, right? We say 2 minus 1 gives us 1. Say 1 minus 0 gives us 1. Then negative 3 minus 1 gives us negative 4. So we could just subtract corresponding entries just like we had in for addition. Okay, so that was nice. Probably just do one more example. This example will consist of a lot of concepts, from subtraction to multiplication of vector by scalar. So okay, we're not going to use diagrams for this, we'll just do it algebraically. So let's see, for a solution, let me use this short for solution. We have 3 times vector v. Of course, we know how to compute that. 3 times vector v just means multiply every entry by 3. That's triple every entry. That will give us 6 and negative 9. Okay, so to have the same direction as vector v, but the magnitude will be increased or will be tripled. Then we have vector w as this, but we need to multiply it by 4 and then subtract. So we say multiply by negative 4, so that we will add these two together, right? So we multiplied each of these entries by negative 4, so it should give us negative 4 and then negative 16. Then the next thing we'll have to do will now be to add these two together. That is how we get the negative result, right? So that will give us 3v minus 4w as, so what is the sum of this and that? Okay, because of the minus in between. Okay, so that will give us 6 plus this entry, that should be 2, and then negative 9 plus this entry, that should be negative 25. So this right here is the result. So this is the result, right? That is very simple. So you've been able to do up to this point, it means you've mastered the art of adding two vectors, subtracting, and then multiplying vectors by scalar. So we could give you the following work to do. Maybe you could just say a little exercise, right? So maybe let's just give up to 2. So we say for the first one, compute, let's see, compute u minus 4v, and then maybe we say compute negative u minus v plus w. Okay, let's just make it in 2D. U is given by, if u is given by 1, 0, that's same thing as unit vector pointing in the I direction. That's it. And then maybe v is given as negative 2i minus j, and then w is given by, let's say, 3j minus 4i. Good. So you want to compute a and b, right? That's your work. You could do that, put the solution or your answers in the comment section. I hope you enjoyed this video. Please don't forget to subscribe to my channel, share the video with your friends. Of course, if you like, just comment, and maybe you want me to do some example concerning vectors, right, that we've created, please just put it in the comment section below. Okay, we'll continue from our next video.